Well, this 2012 thing has a lot of people concerned. But I'll tell you what, our next guest, Mr. David Sereda, is an extraordinary individual, and without any further ado, please come into the global living room, won't you, sir? And let's talk about all these wonderful things that you're involved in, from the early sunrise in Greenland to the evolving consciousness of mankind and maybe even a little hope for humanity. Welcome.
Thank you, John. Good to finally meet you and to be on the show with you tonight.
Well, I'm glad that you could make it. Say, what's up with this 2012 thing, and why is so much stuff happening here, and why are all these airports changing their runway markings? Because the direction of magnetic north is changing so much.
Well, it's the mainstream media kind of eludes the real truth about what's going on. I mean, we can see directly from NASA that the natural drift rate of magnetic North Pole in the 20th century was 10 kilometers per year drifting towards Siberia. But in the 21st century, their data suggests we're at 40 kilometers per year drift rate. So we have a sudden radical increase of 4 times drift rate over the previous century. So something's happening. And then when they announced on NPR News and CNN that they had to change the runways, they made it look like, okay, we waited too long to do this. And when they do, there is a natural drift rate. But the natural drift rate actually drifts to and from you have the physical North Pole, and then you have the magnetic North Pole. And so what happens in a laboratory, if you take a magnet, a strong magnet in your hand, this will be really easy for people to understand. The physical Earth is a physical magnet. We have a molten and a solid iron core and nickel core in the center of the Earth. In fact, it was previously thought, because the magnetic field around the Earth is so weak, that the Earth's core had a weak magnetic field. But just recently, and this is very, very new, for the first time we've measured the Earth's magnetic field at the core. And it's actually at 25 Gauss, which is actually incredibly strong. I mean, if we were living in a field of even 2 or 3 Gauss, it would actually melt our brains. We're used to living, in an environment in the milligauss range. I mean, we're lucky if we even have 1 milligauss of background radiation living in a city with all of the cell phones and all of the, TV transmission lines. So the Earth's magnet is quite strong. And if you hold a magnet in front of a radio transmitter, it vibrates. So what happens in the solar system is that the sun sends electromagnetic pulses to the Earth, and like a radio transmitter, and because the Earth is a magnet, it wobbles. It actually vibrates. And in that vibrational pattern, we get changes in the alignment of the north magnetic field, and the physical magnetic field is the physical magnet, and it vibrates in correspondence to that magnetic field vibration. So what's happening now is an acceleration. There's no doubt that in NASA's data that we see a huge increase in the drift rate. But what is utterly astounding in the way the media kind of buried the story of the Greenland early sunrise is that Greenland normally goes into, just like in Alaska, you get the land of the midnight sun. So you get, the sun never really sets in the summer for a period of time, depending on how far north you live. And the same thing happens in the dead of winter. So, this town in Greenland, it reported that the sun rises every year on the 13th of January for the first time coming out of that darkness.
Right.
And it rose on January the 11th at 1 p.m. So you have 1/11/11/2011. So you have, the first, hour. So it's all 11. It's kind of like a mystical number. You wonder, like, that is that a coincidence that this happened? And so everybody, well, it must have been the ice melting. And that this is really laughable science. In fact, in Time magazine, most astrophysicists disagreed with the ice melting because that's the first thing they said. Oh, we can't believe that the sun would rise 2 days early. Because if you take the 24,000-mile circumference of the Earth and you see, this is on a flat two-dimensional plane, that there's 365 days in a year, so, roughly 360 degrees, turning around the sun. The planet Earth makes one revolution around the sun per year on its tilted axis. So 1 degree, what is 1 degree on the horizon out of those 360 degrees? Well, with our 24,000-mile circumference, 1 degree is about 67 miles, roughly. It's very close to that. So for the sun to rise 2 days early, of course, it's not a full degree to rise 2 days early. In fact, it's nowhere near that. But a mile is 5,280 feet. That's just 1 mile. So you imagine how much ice would have to melt in a single year for that theory to be correct. And you would have to melt miles of ice for that theory to be correct. Many miles. I don't know the exact number, but it's a full degree is 67 miles. So that's 67 miles of ice to have a full degree change in the Earth. That's the physical Earth. That's not the Earth's magnetic field. So with all the hoopla and the the cover-up of the story, it was always just the melting ice, but in Time magazine they disagreed. Well, I found research online in the actual town in Greenland where this is actually occurring. A local resident took out his compass. His name is Johnny Tarhanen, and it's hosted at poleshifting.com. And he measured this compass on the 11th of January and noticed it was 3 to 4 degrees off of true north. 3 to 4 degrees.
That's a lot.
That's 67 miles times 4.
Yeah.
That's huge. And then by the 14th of January, it went back to normal. Now, that is incredible because let's get a bigger picture of what's happening. Because first of all, we see a compass is measuring the magnetic field, not necessarily the physical Earth. But to get an early sunrise, and this is a huge subject because, well, some scientists are saying the ice is melting. Other scientists are saying because the ice is melting, the mountains in Greenland are pushing up because they don't have all that weight on anymore. So there's no way they can win the argument that that's what happened. And then you understand that the physical Earth would have had to wobble by at least a degree or possibly less to have a 2-day sunrise. But that's a lot, even if it's miles. Now, what happened? Let's go earlier, back in the picture here. Because we see from geological sensor data, we have these earthquake sensors placed all over the planet. They're distributed in various places. And when an earthquake goes off, the sensors that are further away from the quake get a weaker signal. But on December 22nd of 2010, suddenly all the sensors all over the Earth all went off with a full signal strength at the same time. This wasn't an earthquake. This was like a vibration. Our solar system is traveling at about 11 million miles per day around the Milky Way galaxy. So we're entering new fields of space every single day, all the time, that there's no way we can predict what will happen when the solar system travels through those magnetic fields. And it's really incredible because what happens is with this theory of 2012 is that we're going to go into this new energy, and there's going to be either a big shift of energy that's going to affect every living thing on the planet, including the planet itself, and possibly trigger Earth changes and earthquakes, which could help explain all of the drastic things that are happening right now. So when you go into a new energy field, changes are very sudden. You get these sudden vibrations, and so there it was. Everybody missed it, and I got this email on the USGS site, and certainly it is very different than the normal background of earthquake data. You get these strong spikes in one location and weak spikes or no spikes in another location. But this was every sensor in the world at the same time.
It's amazing.
December 23rd, the next day, the largest storm ever recorded on Saturn erupts. In fact, the storm is still going on today, and it's far bigger than our planet, which is proof that the whole solar system was entering a new field of energy that was vibrating everything. And then suddenly, within days, you talk about the 1st of January, you have the birds dying and things falling out of the sky.
Oh, yes.
And then I'm just going through a chain of events here, right? And then all of a sudden, on the 11th of January, which is a 11111, you get this possible wobble in the physical field of the Earth. Now, prior to that, I had gotten emails from private physics conferences where they stated that some of the recent solar flares that we've had, which are quite powerful, they've seen magnetic north wobble 500 miles just momentarily and then come back.
Only 500? And then come back?
And then come back. So, that's private data. But 500 miles is not quite 10 degrees, right?
Right.
Because 67 miles per degree times 10 is 670 miles. But that's a long way, a 500-mile wobble. What happens with a physical magnet in a magnetic field is if the magnetic field strength changes or shifts for long enough, eventually the physical magnet will be affected by that movement. And that's when you get a pole shift.
David, tell us what vibrations and magnetism and electromagnetic energy means to the human being. I have often wondered if it was a very good idea for all these. Of course, I'm delighted to be broadcasting with you over countless numbers of them, but I've wondered what effect even big television and radio transmitters have on the human condition. I couldn't help but notice one of the popular jogging paths has some high-tension power lines running over them, and all the treetops are all distorted and so forth. So I suppose electromagnetism, solar bursts of electromagnetic radiation can be your friend, can be detrimental, yes?
Oh, well, absolutely. I mean, let's first start with measuring. I've spent the last several years developing technologies in the lab to firstly measure. I personally measured almost 1,000 people's millivolts in their electrical bodies. We are electrical systems. We have nerves that are like wires. We're like a liquid crystal semiconductor. We have water, minerals, and we have nervous systems that run positive and negative ions. And no two persons has the same body voltage, and that is because of either not getting enough proper minerals in their diet or not getting enough contact with the earth energy. And so some of the things that I've done is I've developed technologies, quantum energy generators, where I've been able to vibrate crystalline stone pendants and jewelry and put them in contact with people and measure the changes in their electrical field. We are so weak in electrical energy that on the surface, the average person might have 100 millivolts in their nervous system, which is a really, really weak field. Using these things called squids, which are these quantum sensors that can measure the electromagnetic field radiating from the human being's heart, a dog or a cat or even a leaf. I mean, these sensors are so super powerful that they can actually prove and sense the fields of energy that radiate off our body. And then, later we developed, Konstantin Korokov in Russia developed the most advanced human aura cameras. They can actually see the human energy field. And when you understand how electromagnetism coming from the sun affects living things, and how weak that field from the sun is by the time it gets to our planet and our biological systems, we're so sensitive that the tiniest changes in electromagnetic fields can alter our DNA. Our actual DNA can change. Now, it was previously thought by medical doctors and biologists that energy was the ruler of the universe, that energy was telling the biology or the matter of the planet what to do. So we imagine our planet moving at 11 million miles a day around the galaxy, and we're rising north above the galactic plane at over 300,000 miles a day. We're going faster than any spaceship has ever traveled. And so what happens is these super sensitive organisms that we are, and many of us are too weak, when we suddenly receive a huge impetus of energy, of cosmic energy. It affects our consciousness